Hello, my name is Paul Stevers, and I'm going to introduce you to some new business opportunities that can help mitigate carbon emissions on a large scale. These opportunities have emerged due to advances in technology, growth of facilities for carbon storage, and increased availability of climate finance. For the purpose of this presentation, carbon emission reduction and removal from the outside air are both considered to be carbon mitigation measures. These business opportunities can be scaled globally. The world is getting warmer at an increasing rate. Shown next is a short video segment that illustrates how the warming trend is correlating with rising atmospheric CO2 levels and how these levels are rising at an increasing rate.
Rising CO2 levels have been correlating closely with rising global temperatures since 1880. This graph shows rising CO2 levels on a shorter timescale as measured at the Mauna Loa Observatory in Hawaii. On an even shorter timescale, you can see average CO2 levels have continued to rise despite a global economic slowdown from the coronavirus pandemic, which is shown by the black line. The red line on this graph shows the seasonal variations.
Therefore, carbon emissions need to be mitigated on a much larger scale than what has been occurring. In addition to expanding carbon-free energy generation and nature-based solutions as fast as possible, the world needs to implement carbon capture on a very large scale. This includes from industrial sources such as power generation and directly from the outside air. Once CO2 is captured, it can be utilized for a range of uses, including vertical farming as well as being sequestered in the ground. Fortunately, there has been a rapid progress in several complementary areas, including carbon capture by a range of technology communities, including these key ones shown next. There are 4 technology communities that have and are continuing to make considerable progress, but are largely operating independently of each other. This includes the direct air capture, or DAC community, the carbon capture, utilization and storage, or CCUS community, the energy storage community, and finally, the renewable energy community. In addition, there are several industrial clusters around the world that have or are developing carbon capture and storage capabilities. As a result, progress can now be further accelerated by companies taking the initiative to develop projects in collaboration with the relevant technology communities and accessing available financing. This would result in a faster rate of development and scale-up of technologies to reduce carbon emissions. Shown next are some example technologies that have been developed and are being implemented by companies in these communities. The direct air capture, or DAC community, is growing quickly. Shown here are 4 DAC companies and their respective technologies. The first is Carbon Engineering's direct air capture solution, which captures carbon dioxide through a series of chemical reactions and returns the rest of the air to the environment. Then there is Climeworks' DAC technology, which has recently commissioned the world's largest DAC system in Iceland. Next is Global Thermostat's DAC Plus solution that can capture CO2 from both the outside air and a natural gas power plant. Lastly is TerraFixing's carbon capture solution, which has developed a process that works most efficiently in cold and dry climates. Shown here are examples of innovative technologies that have been developed and are being implemented by 3 different technology communities. The first is the Elm cycle by Net Power, which enables 100% capture of CO2 from power generated in a natural gas plant. The next is a large wind farm by Vestas Wind Systems that has been manufacturing and improving this technology for more than 50 years. Finally, here is an energy storage technology by Enervenue, which developed a low-cost version of a nickel hydrogen battery that has been used in space by NASA for more than 30 years. Enervenue indicates that it has a 30-year plus lifespan and can complete more than 30,000 full cycles without degradation or usage restrictions. Each of these technology communities include these components to help them create new as well as innovate existing products and processes. Research centers support the development of both technologies and improving existing technologies. The business incubators and accelerators facilitate the creation of new and growth of existing companies. Some research centers include a business incubator in their facilities. As a technology community grows, the commercial segment can become very large. For example, the renewable energy community has become very substantial and now includes many manufacturers, constructors, operators, suppliers, and trade associations. In addition to companies initiating projects with the relevant technology communities, progress can be further accelerated by encouraging collaboration between these technology communities. Shown here are the same 4 technology communities as indicated earlier, but working together to accelerate action. By working together, many new projects, including ones in industrial clusters, can be developed and implemented to help accelerate a global scale-up of technologies to reduce carbon emissions. Projects can be constructed in many different configurations. Shown in the next 2 slides are 2 example configurations of technologies that can produce reliable power to the local electric grid while creating substantial negative carbon emissions. This is the first example configuration. It is a combined power system that includes both natural gas power plant and renewable energy farms. The natural gas power plant runs the Allen cycle, which enables 100% carbon capture while it delivers power to the power management system. This power management system is also supplied with electricity from wind and solar farms. To help manage the power more effectively, this power management system includes energy storage to manage short-term power or peaks or shortfalls. If a substantial amount of power is reduced for a longer period of time, such as if there is no wind for a few days, the power management system reduces the power to the direct air capture system of carbon dioxide. In this way, the power management system can maximize reliability of the power to the electric grid. The carbon dioxide that is captured from the power plant or direct air capture system can be utilized in beneficial ways, such as accelerating growth of food in a vertical farm or be sequestered in the ground. This is the second example configuration. It includes a standard natural gas power plant and Global Thermostat's new innovative direct air capture plus system that can cost effectively capture CO2 from both the outside air and a natural gas power plant. All the remaining components in this schematic work in the same way as indicated in the previous slide. One of the substantial benefits of this combination of technologies is that it can be implemented with an existing natural gas power plant. This can increase the utilization of this existing power plant and turn it into a negative emissions facility. There are several funding sources available to accelerate technology development and scale up. This includes venture capital, government grants and related incentives, private grant funding, crowdfunding, and loans. To help companies obtain capital to build a facility, online platforms like Pure can help facilitate long-term offtake agreements for the carbon that is expected to be captured and stored by this facility. As well, to make investments in substantial projects more attractive to investors, these projects can be refinanced with green bonds after they are operational and generating income. Shown here is a map of industrial clusters, which are located in many different areas of the world. Each cluster contains a group of industrial facilities and includes infrastructure to transport captured CO2 so it can be stored in the ground. In some cases, the CO2 is stored locally. In other cases, it is shipped to a different location where it is then stored. Most, if not all, industrial clusters welcome new participants to utilize the CO2 infrastructure. Therefore, these clusters can be good locations to build a facility that includes direct air capture technology. The cost of DAC is quite high at this time, but is declining quickly. For example, the cost of capturing and sequestering a metric ton of CO2 in the new plant by Climeworks in Iceland was reported to be in the range of $600 to $800 US. Some DAC companies are indicating to me that they expect to be able to capture CO2 for less than $100 per ton when their respective technology is being implemented on a commercial scale. Since there are now many companies in the DAC community developing and implementing technologies, organizations seeking to implement projects that will include DAC should explore all their options and select the best ones. To reduce the financial risk of their project and gain more understanding of their best options for DAC, it may make sense to include more than one DAC technology in an initial project. For your convenience, at the end of this presentation, I will provide a link to a web page that will include links to several companies that are developing DAC technologies. As companies gain experience with different technologies and combinations of these technologies in industrial clusters, they can use their gained knowledge and experience to implement in many other locations. These solutions enable several different sectors of the economy to work together to benefit the whole of society. Capturing carbon through these technologies allows oil, gas, and power plant workers to continue working. As well, it helps governments and companies that depend on income from fossil fuels to transition to a low-carbon economy, which is critical for obtaining their support for this transition. The combination of advancing technologies, declining costs of these technologies, new locations to cost-effectively store CO2, and the increased availability of funding is creating huge new business opportunities for individuals and companies. Therefore, we encourage you to learn about these opportunities and how you and your company can benefit from them. Once you decide on the best opportunity for you or your company, we encourage you to develop it in collaboration with relevant organizations, generate substantial profits, and help create a sustainable world for us all. Thank you for taking the time to view this video. If you're interested in more information, including links to websites of organizations mentioned in this video, please visit climatesan.org/ACEM.